Reefs are important to millions of people around the world, whether they know it or not. For many people, reefs provide their daily sustenance. For others, reefs provide economic opportunity. And for still others, reefs provide novel medicines.
Whether it's through tourism, coastal protection, food, you can't put a value on that. And we know that they're endangered right now. The Coral Reef Airborne Laboratory, otherwise called the CORAL mission, is a 3-year investigation to use state-of-the-art airborne as well as in-water measurements. We're looking at a portion of the world's reef system to assess the condition of these threatened ecosystems and relate how they're changing to their environment.
Coral is going to give us, for the first time, a large uniform data set of coral reef condition across several key regions in the Pacific.
The heart of the CORAL mission is the airborne instrument that we have on board called the Portable Remote Imaging Spectrometer, otherwise known as PRISM. PRISM addresses coastal and inland challenges that we have in remote sensing, and it is key to getting the measurements we need for coral.
Right now, state-of-the-art for studying coral reefs is to put on a mask and a scuba tank and collect very detailed data. This provides excellent information about reefs, but it's a limited perspective. Coral utilizes airborne imaging spectroscopy, so we see a whole reef ecosystem. It's a unique perspective for studying reefs.
PRISM will be providing observations 28,000 feet above the ocean's surface, but yet will be able to tell you about coral reef condition underneath the water.
PRISM's a passive sensor, so it actually just collects the signal, which is essentially the intensity of the light from the sun reflecting off the surface or the coral reefs. There you go. And when PRISM sees that, our scientists then analyze the spectra that we collected and are able to determine different features about coral reefs.
We're able to say what that composition of the seafloor is. It's observing what's being reflected, and how it shows that is a spectrum, so basically from blue all the way to red, and it's observing all of that and breaking it down.
It shows some clouds in the area. Let's zoom in a little more.
We come in the morning, do a weather briefing with the pilots and the rest of the team, and decide whether it's a good day to collect data or not based on lighting conditions, cloud conditions.
The amount of time that it takes us to fly that extra portion of the line is only about a minute of that, so why not extend the line a little bit and get a little bit more data.
So our flight lines for this mission are at 28,000 feet. Gives us a wide enough swath to be able to look at a wider range of coral reefs in a very quick amount of time. One of the lines took 7 minutes to collect, and that amount of data that we collected would have taken our scientists' team in the water a few days.
Research standing by. The planes are going over you now.
Thank you.
I mean, there's a path right here.
Flew over, there was actually a team of in-water optics in boats collecting the same information that we were collecting from 28,000 feet.
That's giving us the exact GPS coordinates of our location right now, so that we can correlate the data from the airplane to what we see down here.
At the end of the day, we're going to look at the data that the folks on the boats collected and the data we collected with PRISM and make correlations to validate that we are making correct measurements.
Coral is only going to see 3 to 4% of the world's reef area. And that's not even spread out across the world. That's only a few select regions. So we're missing a whole bunch of the world. If a satellite could make the measurements that PRISM can make from the airplane, I would be ecstatic, because there is a global reef survey, a true global reef survey.